about that Charles law graphs. These graphs, what we are saying that isobars. Why we are calling these graphs are isobars? We are drawing the graphs. We are drawing the graphs volume versus temperature at constant pressure. At constant pressure. So we are using here constant pressure. So that graphs what we are saying that isobars. Isobars. So once see that which type of graphs we can observe. These are very important graphs in the objective point of view. These graphs are very important. Questions are coming on this topic. First, we are going with that volume versus temperature. Here temperature I am taking in terms of Kelvin. It will be like this. Volume, temperature in terms of Kelvin. Okay. So straight line, but it is not passing through origin. If you extended the graph, it will be comes to origin, but it won't be come. It will be like this. Why? Because I previously I told that volume of the gas never be zero. Never be zero. Similarly, if you take that V by T versus volume or temperature, the graph will be like this. If you take volume value or temperature value, whatever it may be, the graph will be coming like this. Okay, the graph will be coming like this. Similarly, if you draw the graph between volume versus 1 by T, what happens? We are getting hyperbola graphs. We are getting that hyperbola graphs. So questions are coming in various forms in this topic. So what type of questions we are getting in the exam? One see that. Suppose I am taking that volume versus temperature. Volume versus temperature. This will be P1, this will be P2 and this will be P3. Okay. If you are extending, we will passing through origin. If you are extending only, okay, otherwise it will be like this. So in the Boyle's law graphs, what we are doing to explain the relation between the various temperatures, okay, we are using that one ideal gas equation. What is that? PV is equal to NRT. Okay, this is the relation we are using to explain the relation among them. Okay, once see that here, if you kept the volume as constant, that means volume is not changing but temperature changing. So this point we are taken as T3. Why? Because the pressure will corresponds to T3. This point here I am taken as T2. This pressure corresponds to temperature T2, and this point I am taking that T1. Why? Because this P1 corresponds to T1. What is the relation between the pressure and temperature? Pressure is directly proportional to temperature or not? Whenever your increasing the temperature, pressure of the gas, what happens? Increases. Okay, directly proportional. Directly proportional. So if pressure increases, temperature increases. If temperature increases, pressure automatically increases. Directly proportional. So the relation between these, what happens? P3 greater than P2 greater than P1. Okay, for suppose here I kept temperature constant here. Here volume and temperature. Volume and temperature. So I am taking that three types of graphs here. This will be P1, this will be P2, and this will be P3. Okay. If you are extending means they are passing through origin. Now I kept temperature will be constant. Temperature will be constant. Okay. Here I am writing neatly because this is very important to understand. Then only remaining graphs we can understand easily. See that. Volume, temperature. This is P1, this is P2, and this is P3. If you are extending, they will pass through origin. Otherwise, it not be touching that origin point. This will be taken as P1, P2, and P3. So in this, what we are doing, volume is taken as constant. Okay, but temperature changes. Now we are fixing the temperature constant. We are fixing the temperature constant. That means temperature is not changing. If it is going increasing, if it is going decreasing. But in this manner temperature is not changing. This point is not changing. See that. But volume, what happens? We are not fixed that volume. So volume will be changes. At P1, corresponding volume V1. At P2, corresponding volume V2. At P3, corresponding volume will be. What is the relation between volume and pressure? Volume and pressure inversely or not? Pressure is inversely proportional to volume. That means if you are increasing the pressure, volume what happens? Decreasing or not? See that this is high pressure. At high pressure, this volume what happens? Very low. This is low pressure. Its corresponding volume what happens? It will be more. See that this box. At high pressure, for my convenience I am taking this is 1 atmosphere, this is 3 atmosphere, and this is 5 atmosphere. Okay, at 5 atmosphere volume will be very less, small box. If you are coming to 3 atmosphere, volume little bit. Okay, if you are coming to 1 atmosphere, volume will be more than V2 and V3, isn't it? So at high pressure volume will be decreases. So what is the relation here? P3 greater than P2 greater than P1. It's obeying the formula or not? It's obeying the formula or not? Definitely it is obeying. Okay, if pressure increases, volume decreases. If pressure increases, volume decreases. Inversely proportional. That is the reason why pressure increase చేస్తే వాల్యూమ్ ఖచ్చితంగా బాగా తగ్గాలి. ఖచ్చితంగా ఇక్కడ బాగా తగ్గుతుంది. Okay, so just like we can explain the various graphs. Similarly, if you are coming to this graph, okay, V by T versus here volume or temperature, any term we can take that. Here I am taking that volume. What is the graph here? is corresponding P1, this is P2, and this will be P3. Now we can explain by fixing the volume. Okay, if you are not changing the volume is not changing. Why? If you are going that, volume what happens? Increases. If the volume, if you are coming like this, volume what happens? Decreases. So at this point volume is neither decrease nor increase. Okay, it will be constant value. See that by using this relation V by T, remaining terms NR by this will be taken as constant. Okay, this will be taken as constant. Okay, see, not constant. We have to explain with present. We have to explain with present. That means NR by T. Okay, this will be taken as constant, means V by T is equal to constant into 1 by P. So V by T is inversely proportional to 1 by P. Okay, what is the relation between V by T and pressure? V by T is inversely proportional to pressure. V by T is inversely proportional to pressure. Okay, see that. At P1, its value will be V1 by T1. At P2, its value will be V2 by T2. At P3, its value will be V3 by T3. That means whenever you are increasing the pressure, V by T terms what happens? Should be low or high? Definitely it will be low. Okay, so pressure is inversely proportional to V by T. So that is the reason we see that at high pressure, P3 is high pressure here. So the box will be low. The box will be low. Okay, after that P2, the box will be somewhat high when compared to this. P1, it is a very low pressure here. At low pressure, V by T value is here more when compared to P2 and P3. That is the reason the box will be more. Okay, it is obeying the formula or not? V by T is inversely proportional to pressure. If you are increasing the pressure, V by T terms decreases. Okay, if you decrease the pressure, V by T terms what happens? Increases. Okay, so what is the relation here? P3 greater than P2 greater than P1. Inversely, not directly here. Pressure increases, V by T terms decreases. That is the reason we are getting that relation. Okay, so just like that we have to explain these values. Similarly, if you take pressure constant, if you take that V by T terms constant, volume is increasing. Volume is increasing. Just like we can explain in that manner also. And one more thing. Here V versus 1 by T graph. I told you that it will be hyperbola. This will be P3, this will be P2, this will be P1. Same thing. If you fix that one value, suppose if you fix that volume, P3, P2 and P1. If you fix that value,